Today's lesson is about calculating the volume of pyramids and cones. Your formula for volume of a pyramid is area of the base times height of your pyramid divided by 3. Notice how it's really the equation for volume of a prism, area of base times height, divided by 3. And we'll talk more about why that is later, but really any pyramid takes up a third of the space in the smallest prism that can hold it. So there's lots of different types of pyramids, square-based pyramids, hexagonal-based pyramids, but today we're focusing on square-based pyramids. So you have a little bit of a shortcut in terms of area of the base because you know that these are square pyramids. You know the base's area will just be 12.5 squared. So you could just plug that in. When you do area of base times height over 3, you could just get away with plugging it all in at once. Pause here and try the rest of the front page. Check your answer for question 2. If you chose to write your final answer in scientific notation instead, that's acceptable as well. It's very long. Notice how for these formulas, because we want the volume, not the surface area, we actually need the inside height of the pyramid, not the lateral height. That's going to be important because sometimes they might tell you the wrong height. So for number 3, for example, check that you plugged in 30, not 34 for the height, because for volume, for the space inside your shape, we want the inside height, how tall it actually is, not the slant height. So sometimes you have to choose between heights to figure out which one you need for the volume. Sometimes they don't tell you the actual inside height of the pyramid at all. When that happens, draw the triangle. If the slant height is 15 and the base is 18 yards long, you know that this triangle has a base of half of 18. So the base of this triangle is 9. The hypotenuse is 15, and then you could solve for the actual height of the triangle using Pythagorean's theorem. Once you have the height of your pyramid, now you could plug it all in. Don't forget, for volume, your units are cubed because we're talking about 3-dimensional space inside of your shape. Now for volume of a cone. So the volume of the cone formula, you could derive it by starting with your formula for volume of a pyramid, area of base times height all over 3. But because a cone has a circle as its base, you could plug that in for area of the base. So it becomes pi r squared times h over 3. So you could plug in your height and your radius and leave your answers in terms of pi. Don't forget your units. Pause here and try the rest of the page. For number 6, there's 2 things they're not telling you that you need. They're not telling you radius, and they're not telling you actual height of the cone. However, radius is quick to solve for, you just half the diameter. You could draw your right triangle to solve for the height of your cone using Pythagorean's theorem. So if you got as your final answer something between 54.4 pi and 54.6 pi meters cubed, well done. Now, Cavalieri's principle that says that oblique shapes have the same volume as they would if they were balanced and right is going to help you here. Even though these are leaning oblique cones, they're going to have the same volume as if they were centered. So you still use a height of 6, you still use a radius of 4, and you plug it all in. Now, sometimes they're going to give you a word problem. When that happens, it's always a good idea to summarize the information they're asking for and then information you already know on the side. We know the volume, we know the height, and they're asking for the radius. Since the shape we're talking about is a cone, start with the cone formula and plug in the things you know, the volume and the height. From there, your job is to get r squared by itself, so you can cancel out the over 3 by multiplying both sides by 3. Then you could cancel out the times 8 and the times pi by dividing both sides by 8 pi. And then you could cancel out the square on the r by square rooting. And you should get r equals 3 centimeters. Don't forget your units on your radius. Well done, everybody. When you're done with the notes, don't forget to turn in a picture of them on Schoology.